page 223, numbers 1 through 8. Let me quickly turn over there. Hold on 1 second. Numbers 1 through 8 say to perform the matrix operations. So number 1, we're going to add these two matrices together. Now remember, you cannot add two matrices together unless their dimensions are identical. This is a 2 by 3. And this is a 2 by 3, okay? They're identical, so we can add them together. And I'm not being lazy, but this is Algebra 2. You guys can add numbers together. So I'm just going to slide this out of the way. 0 plus 10 is 10. 1. 1 plus 3 is 4. Negative 5 plus 11 is 6. 4 plus negative 2 is 2. 1 plus 8 is 9. 6 plus 3 is 9. Okay? So when you're adding two matrices together, you simply add an element with its corresponding element to get out your answer. Okay? Alright. Moving on. Number 2, we're going to subtract two matrices. Now remember, you cannot add or subtract matrices unless they have identical orders or dimensions. This is a 2 by 2. This is a 2 by 2. Are they identical? Yes, they are. So you can subtract them. Now, you guys know how I like to do it. I make this a positive sign, and I change all of these signs. That's how I roll, okay? That's just how I like to do it. So, 15 plus 0, 15. 4 plus negative 9, negative 5. 3 plus negative 2, 1. 12 plus negative 7, 5. There we go. Okay. Really can't make it any simpler than that, guys. Number 3. Okay. We have a 3 by 3 and a 3 by 3. So we can definitely subtract them. I'm going to very quickly go like this. And then make this negative, 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 positive, negative, negative, negative. And then I'll go very fast, okay? 5 plus negative 6, negative 1. 1 plus negative 7, negative 6. 10 plus negative 3, 7. Negative 1 plus 0, negative 1. 0 plus negative 14, negative 14. 0 plus negative 6, negative 6. 2 plus negative 1, 1. 3 plus 1 is 4. 4 plus negative 2 is 2. Okay? So there we go. Whenever you're subtracting two matrices, first make sure that they have the same order, the same dimensions, and then if they do, I recommend changing this sign and adding. Now some of you could have done it like this. Some of you might have said, okay, negative 5 or 5 minus 6, negative 1. You might have said 3 minus a negative 1 is 3 plus 1, which is 4. That's fine. For me, I'd rather make one change here, change all of these, and then add. That's just me, okay? Number 4. Okay, let's add these two matrices together. This is a 3 by 2, 3 rows, 2 columns. This is a 3 by 2. This is a 3 by 2. So we can definitely add them. So here we go. 6 plus 2, 8. 10 plus 1, 11. 9 plus 0, 9. 6 plus 7, 13. 4 plus 4, 8. Negative 1 plus 7, 6. So we simply add an entry with its corresponding entry. Okay, that's all you have to do. Okay, pretty simple. Alright, moving on to number 5. We're going to simply, this is called a scalar right here. Alright. And we're going to multiply it through the matrix times these numbers. So whenever there's a number outside of a matrix, we multiply it through. It's really quite simple, okay? And so here we go. 3 times 4, 12. 3 times 6, 18. 3 times negative 1, negative 3. 3 times 10, 30. 3 times negative 5, 15, or negative 5, negative 15. 3 times 2, 6. 3 times 2, 6. 3 times 11, 33. 3 times 1, 3. That's simple, guys, okay? So whenever there's a number outside of a matrix, it gets distributed or multiplied through times every element or entry, whatever you want to call them, inside of the matrix. Okay, this is called a scalar. Um, called scalar multiplication, or multiplying a number times a matrix. Alright? Okay, number 6. Exact same thing again, guys, so pretty simple. I mean, I just can't make this any simpler, okay? I'm not going to go through each number like I did in this last problem here where I said 3 times 4 is 12. I'm not going to do that, okay? Take 8 and multiply it by each number. 8 times 3 is 24. 8 times negative 9, negative 72. 8 times 6 is 48. You take this 8 right here and multiply it times every number in this row, every number in this row, every number in this row. And you'll get this out right here, unless the book made a mistake. I don't think they did, but that is the answer you should get out. Okay? Alright, moving on to number 7. Okay, now we have two matrices inside of a parentheses. Do you see that? Here's the parentheses. So, could you take this negative 2 and multiply it times all the numbers in here and all the numbers in here? Yes. And then subtract the two matrices? Yes. But why would you want to do that? Why would you want to make these numbers here become bigger by multiplying them by 2? I would first subtract the two matrices. And whatever you get out, put it right here, and then multiply this matrix by negative 2. Now, when I say subtract these two matrices, you know what I mean. Make this a positive and change all the signs. So we have a 6 and a negative 5, 1. We have a 4 and a negative 10. We have a 0 and a negative 1. And we have a 3 and a negative 3. There we go. So just like that, I subtracted the two matrices. Or you can say I changed the signs and added. Now take this 2 and multiply it through the matrix, and you'll get a negative 2. All the signs are going to change. You have a negative number you're multiplying through. Negative 2 times 1, negative 2, negative 2 times negative 1, positive 2. Negative times a negative, positive, and 2 times 0 is 0. So there's your answer. Okay? So again, if you wanted to, please listen carefully, students. If you wanted to, you could definitely take this negative 2 and multiply it through. Negative 12, 0, negative 8, negative 6, minus, and then negative 10, negative 2, negative 20, negative 6. I took the negative 2 and multiplied it times all of these numbers. Now subtract these two matrices. Make that a positive. Change all of your signs. You get a negative 12 and 10, negative 2, negative 8 and 20, positive 12. 0 and 2 is 2. Negative 6 and 6, 0. So either way is fine, but I definitely recommend first subtracting the two matrices, then multiplying by 2. Same thing here. You're definitely welcome to take a negative 3 and multiply it through, okay? First, I would not though. I'm going to add my two matrices first. Okay, so here we go. 4 and 3 is a 7. 7 and negative 5 is a 2. 1 and 6 is 7. Negative 2 and 0 is negative 2. Now take your negative 3 and multiply it through. Negative 3 times 7, negative 21. Negative 3 times 2, negative 6. Negative 3 times 7, negative 21. Negative 3 times negative 2, positive 6. Okay, so add the two matrices, then multiply by negative 3, and that will give the answer. Okay, moving on now. Number 9 says to multiply the matrices together. So remember, you must run a test. If you don't run this test, you're going to miss some on your test. Okay, you must run a test. So here we go. Here's how you run the test. You write the order of this matrix and the order of this matrix. Now, the orders do not have to match. If they do, that's fine, but they don't have to. What has to match are these two inside numbers. And do they match? Yes, they do. Your outside numbers, 2 and 2, are the dimensions or order of your answer. So you have a 2 on the outside here, a 2 on the outside here. That means your answer is going to be a 2 by 2. Okay? That's very important you understand that. Now students, after you've determined that yes, you can multiply them together. And let me stop and say this: if these two numbers right here didn't match your inside numbers, then you would say no solution. Okay, you can't multiply them together. But now that we've decided that yes, they can be multiplied, and here's the type of matrix we're going to get out. Now that we've decided that, here's what you do: you take this row times every column until you've multiplied it by every column. So row times column, first times first, -1. Next times next, 0. Add those together, you get a -1. Now take this row times the next column right here. First times first is 1. Next times next is 0. Combine those and you get 1. Okay? Now, we're going to slide this down here to the next row. And it looks like our first row is pretty good so far. Okay, row times column, here we go. First times first, -4. Next times next, +27. Combine those, 23. Now take this row times this column. First times first, +4. Next times next, +18. Combine those and you get 22. And that should be the correct answer. Alright, so there we go. Back it up and watch it again if you need to. Practice, practice, practice. Okay, number 10. Okay, let's run our test. This is a 3 by 2. I'm sorry, this is a 2 by 3. 2 rows, 3 columns. This is a 3 by 3. Yes or no? Do your inside numbers match? Yes, they do. Your outside numbers are 2 and 3. So that means your answer is going to be a 2 by 3. So 2 rows, 3 columns. Okay? 2 rows, 3 columns. And here we go. We're going to start off with taking this row here times this column, then this column, then this column. First times first, negative 36. 6 times 5, +30. 0 times 3, 0. Combine, -6. Okay, moving on. Now this row times this column. 6 times 1 is 6. 6 times -2 is -12. 0 times 8 is 0. Combine, and you get a -6. Now take this row times this column. 6 times 4 is 24. 6 times 1 is 6. 0 times 0 is 0. Combine those and you get 30. Hopefully our first row is right. It's easy to make mistakes on these. Okay, we're good so far. Now, let's go ahead and take this next row times each one of these columns. Okay, so here we go. Row times column, 1 times -6, -6. -1 times -2 is +2. That's incorrect, sorry about that. 1 times -6, -6, -1 times 5 is -5, and 5 times 3 is +15, which would give you a 4. Row times the next column, 1 times 1 is 1, -1 times -2 is +2, 5 times 8, -8 is -40, combine and you get -37. And now row times your last column, 1 times 4 is a +4, -1 times 1 is a -1, 5 times 0 is 0. Combine those and you get a 3, okay? And yes, we're looking good, okay? So that's it, guys. It just takes practice, 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 okay? Number 13. We're multiplying 2 matrices together, so run your test. You have 1 row and 4 columns. This is a 1 by 4. This has 4 rows with 1 column, so this is a 4 by 1. Do your inside numbers match? Yes, they do. Your outside numbers are 1 and 1, so it's kind of funny. You're going to get out a 1 by 1. Alright, 1 row, 1 column, so basically 1 row, 1 column. That means 1 number. 1 number, and that's it. Okay, so here we go. row times column. Here we go. 10 times 1, 2 times 0, 1 times negative 2, 5 times 3. Combine all of those numbers and you'll get 23. So there's your 1 by 1. Okay? Okay, moving on. On to number 15. Now the directions for 15 and 19 are to find the determinant. Find the determinant. Okay? So here we go. For a 2 by 2, we're going to multiply up and change the sign. Negative 6, I'm going to put a positive 6. Multiply down and do not change the sign. Positive 6. Combine those and you get a 12. So your determinant is 12. Let's go over that again. Whenever you're, well, first of all, a determinant can only be found on a square matrix. Please don't forget that. If I give you a non-square matrix on a test and I ask you to find the determinant, you would put can't be done or no solution. You only have determinants on square matrices, okay? Number 2, if it's a 2 by 2, you simply multiply diagonally up, left to right, and whatever you get, change the sign. Multiply down, left to right, and whatever you get, do not change the sign. Combine those two numbers, and that's going to be your determinant. Now, number 16 is a little different. Number 16 is a 3 by 3, okay? So in a 3 by 3, I'm going to copy it again just so we have some room to work here. Make sure I copied it correctly. Okay, now in a 3 by 3, when I ask you to find the determinant, first of all, don't forget, if you ever see just bars on both sides, that means find the determinant. Okay, alright. But when it's a 3 by 3, you have to multiply the first and the second columns. You have to copy the first and second columns over again. So your first and second columns must be copied over again and put right here, just like that. Okay. So that's the first thing you have to do, is copy your first column here, your second column here. Now, next you're going to multiply up 3 times, and every time you do, you change the sign. So multiply up, you get 60, so I'm going to put a negative 60. Multiply up, I get a negative 24. I should put arrows so we don't think those are negative signs. Multiply up, and we get a negative 24, so I'm going to put a positive 24. And then multiply up, and you get a negative 2. I'm going to put a positive 2. Okay? Now we're going to multiply down, and do not change the sign. 2 times 6 times 2 is a positive 24. 1 times 3 times 2 is a positive 6. 5 times a negative 1 times a negative 4 is a positive 20. So if I combine all of my positive numbers, I get 48. 48. 52, 58. So all of my negative numbers, negative 60. All of my positive numbers are 58. I'm getting a negative 2. Is that right? Okay. Somewhere I've made a mistake here. Let's see. 60, negative 60, negative 24, positive 24, negative 2, positive 2. 24, 6, positive. Okay, 48. 50, 58, negative 60, negative 2. Okay, what do we do wrong here? Okay, guys, I'm sure you saw my mistake. It'd be a positive 20, not a positive 2. So here we go. We have, add up all my positives. We get 48, 50, 56 plus 20 would be 76. So add up all of your positives, you get 76. Add up all of your negatives, negative 60. Combine those two and you'll get positive 16. Okay? So sorry for the mistake, but that is how you would find that determinant. So on your test, make sure you know how to find the determinant of a 2 by 2 and a 3 by 3. Now, moving on to 23, they want us to find the area of the triangle, okay? Well, you've been taught what to do. You've been taught that you can definitely use the determinant of a 3 by 3 to find the area of a triangle as long as you have the ordered pairs of the vertices of the triangle. Now, the vertex of a triangle, there's 3 vertices. 1, 2, 3. So when I say the vertex or the vertices of a triangle, I'm referring to their corner points, okay? But if we know those 3 ordered pairs, we can find the area. Pick up any ordered pair, it doesn't matter which one, and put it right here. Pick up another one, it doesn't matter which one, and put it here. And then pick up your last one and put it over here, it doesn't matter which one you put first or second or third. Then you always put ones here, always. Then outside here, you always put a 1/2, always. Okay? Now, we're going to find the determinant of a 3 by 3, so I just went over this in the last problem here. You got to copy the first 2 columns over again. Alright? So we're going to copy those first 2 columns, put them right there. Okay? And now we're going to multiply up 3 times and multiply down 3 times. That gives us a -9, so I'll put a +9. This will give me a +8, so I'll put a -8. And this will give me a -6, so I'll put a +6. Combine all of those numbers and you get +7 for those 3 numbers. Alright, now let's multiply down 3 times. 2 times 3 times 1. Do not change the sign. +6. -1 times 1 times -3, that's a +3. And 1 times 6 times 4 is a +24. So we get a +33 when I combine those numbers. So +7, +33, the determinant is 40. Now remember, whatever you get out for the determinant, you then must multiply that by 1/2. Now, obviously 1/2 times 40 is 20, so the area of this triangle is 20 square units. Or you can write your answer like this: 20 units squared. Either way, that will be the answer. Now, remember, pretend for a second this was a -7. Pretend this was a -30, which can definitely happen. This should be a 33 right here, shouldn't it, students? My fault. There we go. Anyways, pretend this was a -7 and a -33, so you had a -40. Well, anytime you use this method to find the area of a triangle, if you get out a negative answer, just make it positive. Just make it positive, okay? Because the original formula, well, I'm not going to get into that now, but anyways, your area has to be positive, so just make it positive, and the formula will work just fine. Okay? Alright, moving on to another problem, number 25. Now the directions for number 25 ask you to find the inverse of this matrix. So I'm going to help you find the inverse of this matrix. Step 1, you find the determinant. If I ask you to find the inverse of a 2 by 2, what do? You first find the determinant, so multiply up 15, so I'll put a -15. Multiply down +14. Combine those, you get a -1. So there's your determinant. Determinant equals -1. Step 2, you're going to move some numbers and change some numbers. These 2 numbers right here, you change their signs. These 2 numbers here, you don't change their signs, you move them. So the 2 goes up here to the top left. The 7 goes down to the bottom right. Okay? Next, we take our determinant and we flip it. So -1 is really over 1. If you flip -1 over 1, you still get -1. So after you take your determinant and you flip it, you then multiply it through. Well, obviously, taking a -1 1 and multiplying it through just changes all of the signs. That's all that it does. So I think that's the right answer. Hopefully we didn't make a little mistake somewhere. Yeah, there we are. Now don't forget, watch this, guys. If this matrix here and this matrix here are truly inverses of each other, which they are, you can multiply them in any order, okay? You can multiply them with this matrix first here, or you can multiply them with this matrix here being first, and it doesn't matter. Now usually it does matter with matrices, but when two matrices are inverses of each other, it doesn't matter which one goes first. You will always get out the identity matrix. Anytime two inverse matrices are multiplied by each other, you will always get out the identity matrix. Always. Okay? Alright, moving on to number 28. Practice makes perfect, so we're going to practice again. Okay, step 1, we're going to find the inverse matrix. Again, step 1 is find the determinant. Remember, we just did that. So multiply up, I get a negative 8, so I'm going to put a positive 8. Multiply down, I'm going to get a negative 6. Combine those two numbers, and I get a positive 2. So your determinant equals 2. The next thing you're going to do is you're going to move some numbers and change some numbers. These two numbers here, you do not move them, okay? You change their signs. These two numbers here, you swap them, so the negative 3 comes up here and the positive 2 comes down here. Next, you take your determinant and you flip it. 2 is really 2 over 1, so you flip that and you get 1/2. So we're going to take 1/2 and multiply it through. Now that's done for you right here. 1/2 times negative 3, negative 3/2. 1/2 times 2, 1. 1/2 times negative 4, negative 2. 1/2 times 2 is 1. So this is your inverse matrix up here. Let's go over it again. Step 1, find the determinant. Step 2, change the signs of these two numbers. Swap these two numbers. Step 3, take your determinant and flip it and multiply it through, and that's it. Now, these two matrices are inverses of each other. So if you were to multiply them together, you will get out the identity matrix. And that's a 0 right there. Okay? Alright, moving on to number 20 and 31. Now 31 says, decide whether the matrices are inverses of each other. Now this will take a little bit of work, but remember, if they're truly inverses of each other, we can multiply these two matrices together and we should get out the identity matrix. Okay, so let's see if that happens. First of all, I have a 3 by 3 here and a 3 by 3 here. Do my inside numbers match? Yes. My outside numbers are 3 and 3. So far so good. I will get out a 3 by 3. Now let's start multiplying and see what happens. Here we go. This row times this column. 1 times 1 is 1. Negative 1 times negative 3, positive 3. Negative 3 times 1, negative 3. Combine those and you get a 1. Check. Now take this row times this column. 1 times 3, 3. Negative 1 times negative 9, positive 9. Negative 3 times 4, negative 12. Combine those, you get a 0. Check. Now take this row times this column. 1 times 5 is 5. Negative 1 times negative 16, positive 16. Negative 3 times 7, negative 21. Combine those, you get a 0. Check. So far so good. Now let's move down to the second row. This row times this column. 5 times 1 is 5. 2 times negative 3 is negative 6. 1 times 1 is 1. Combine those and you get a 0. Check. Now this row times this column. 5 times 3 is a positive 15. 2 times negative 9, negative 18. 1 times 4 is a positive 4. That's like, if you combine those, you'll get a positive 1. Check, that's what you should get. And now this row times this column. Positive 5 times positive 5 is 25. 2 times 16, negative 32. 0 times 7 is, 1 times 7 is 7. If you combine those, you will get a 0. Check. So far so good. We'll see what happens in the last row here. Alright, here we go. Row times this column. 3 times negative 1, negative 3. Negative 1 times negative 3, positive 3. 0 times 1 is 0. Combine those, you get a 0. Now row times next column. Negative 3 times 3, negative 9. Negative 1 times negative 9, positive 9. 0 times 4 is 0. Combine those, you get a 0. Check. Now finally this row times this column here, and we better get out a 1 right here, okay? Negative 3 times 5, negative 15. Negative 1 times negative 16, positive 16. 0 times 7 is 0. Combine those and you get a 1. So yes, these two matrices are inverses of each other because when you multiply them together, you got out the identity matrix. Okay? Alright, moving on. Number 33. Now, I'm not sure why they put an X and a Y here. I mean, I know why they did it, but they should be consistent earlier in the school year in this chapter. You guys were used to seeing a really big X here, okay? In fact, I'm not even sure if there was a matrix around. I don't think there was. Let me glance real quick here. Looking back here real quick. No, there was not even a matrix, but that's okay. Just understand that all we're doing, just pretend there's a big X here. That's what you're used to, and that's what you'll see on the test, okay? Alright. Let's solve this matrix equation. Step 1 is we want to first of all find the inverse of this matrix here. Okay, so here we go. Multiply up negative 5, so I'll put a positive 5. Multiply down positive 6, so I get an 11. So your determinant is an 11. Okay. Now, next we're going to swap some numbers around here. So these two numbers change their signs, and then swap the 2 and the 3. Next, take your determinant and flip it, so 11 over 1 is 1 over 11, and now multiply it through. So your inverse matrix is 2 11s, negative 5 11s, 1 11s, and 3 11s. Okay? Now what we have to do is we have to take this inverse matrix and multiply it by both sides of the equation. So, if you multiply the inverse times this matrix, they cancel out, just leaving you with x equals. Now listen to me carefully, students. If you're going to solve this, you next must multiply the inverse matrix times this matrix. But if you don't put the inverse matrix first in your multiplication problem and this matrix second, you will miss the problem. This inverse must come first, and then this must come second. So we have a 2 by 2 times a 2 by 1. Do the inside numbers match? Yes. Your outside numbers are a 2 and a 1. So your answer is going to be a 2 by 1. And so here we go. Row times column. Here we go. Alright. 2 11s times 3, that's negative 6 11s. 1 11 times 2 is a positive 2 11s. Combine those and you get negative 4 11s. Now take this row times this column. Negative 5 11s times negative 3, that's positive 15 over 11. 3 11s times 2 would be 6 11s. Combine those and we get 21 over 11. That's kind of a weird answer, but that is the correct answer. I'm looking right is correct. So basically what I'm saying to you is this. If you take this matrix right here, your answer, and put it right here for x, if you took this matrix here times this matrix here, that's your answer, you will get equals, you will get this right here. That'd be a great way to check your answer on a test or a quiz. Okay? Alright, moving on. Now 35's a little more difficult because you first have to move this matrix over so that this matrix here and this matrix here are all by themselves, okay? So I'm going to go ahead and bring this matrix down. And I'm going to write this just like it was in the book earlier, weeks ago during your homework, a big X here, not this, okay? And then equals, now we're going to bring this over and make it, it's a positive, so we're going to bring it over and make it a negative, okay? So we have negative 5, 0, this matrix right here, minus this matrix here. And we're going to get out, I'm going to make this positive, positive, negative. Negative 5 and 1 is negative 4. 0 and 2 is negative 2. So there we go. Okay? So I brought this matrix over right here and made it negative. Now I'm ready to find the inverse of this and multiply it by both sides to solve the equation. How do you find the inverse of this matrix here? Well, first of all, the first thing you're going to have to do is find the determinant. Multiply up negative 4, I'm going to put a positive 4. Multiply down negative 2, combine, and the determinant is 2. Next, we're going to change the sign of these two numbers here. 4 becomes negative, 1 becomes positive. We're going to swap these two numbers here. So this will be a positive 2, bring the 2 up here, the negative 1 down here. Next, take your determinant and flip it. 2 is the same thing as 2 over 1. Flip that and you get 1 half. Take 1 half and multiply it through. 1 half times 2, 1. 1 half times 1, 1 half. 1 half times negative 4, negative 2. 1 half times negative 1, negative 1 half. So there's your inverse matrix. So you did all of that work to find your inverse matrix. Now, if you take your inverse matrix, students, and multiply it by this matrix here, it'll cancel out, just leaving you with x. Oh, I shouldn't have done that. My bad, students. Okay. I should have left this up here. Okay. Sorry. Okay. If you take, my fault, students, if you take this inverse matrix here and multiply it by this matrix here, they'll cancel out, leaving you with x. Okay. But then you must take this matrix times this matrix also. Now remember, your inverse matrix must come first. It must. Okay. So you take your inverse matrix times this matrix here. This is a 2 by 2. This is a 2 by 1. Inside numbers match. Your outside numbers are a 2 and a 1. So the answer you're going to get out is going to be a 2 by 1. Alright? So here we go. Answer's going to be 2 by 1. 2 rows, 1 column. Alright? Here we go. Row times column. 1 times negative 4, negative 4. 1 half times negative 2, negative 1. Combine negative 5. Now row times column. Negative 2 times negative 4 is 8. Negative 1 half times negative 2 is positive 1. That gives you a 7, or 9, excuse me. So there's your answer. The answer is negative 5, 9. So if you pick up this matrix right here, alright, and you put it right here, right in there, you would take this matrix times this matrix plus this matrix. You would get out this matrix right here. Okay? Back it up and watch again if you need to, guys. Make sure you know how to solve these. Alright? Moving on. Alright, number 44. The directions say to use an augmented matrix to solve. Now, I'm pretty good at making mistakes on these, so hopefully that won't happen, okay? I'll do the best that I can, guys. Alright, here we go. 1, 2, 2, negative 1, negative 1, negative 2, negative 5, negative 6, negative 9, 1, 2, negative 1. Okay, there's the problem. Now, here's where you put your dotted lines. Now what I did is I took my coefficients, put them here, coefficients, put them here, coefficients, put them here, constant terms, put them here, okay? It's called an augmented matrix. Now I'm probably not going to go like this all the way down through. I'm just going to put lines separating them, okay? So for now, I'm going to go like this, and kind of slide this. Well, here's the answer. We'll just go ahead and uncover the answer now and get rid of this. So we're looking to get this answer right here when we're all done. Negative 2, 12, negative 3. Okay, so with that in mind, I'm going to get rid of this, and hopefully we'll do okay. Now let's review. Your goal is to get a 0. I have to stop and think myself. A 0 here, here, and here. Always get this one first, this one second, and this one last, okay? So here we go. If I want to get a 0 here, I wish one of these 2's were negative. So I'm going to multiply my bottom row by a negative sign, okay? So if I by a negative 1, so if I multiply the bottom row by a negative 1, that'll give me a negative 2 here. And I can combine these 2 rows and get a 0 here. So this will become negative, this will become positive, this will become positive, and this will become positive. Now add this up to the second row and change the second row. So my first row stays the same. My second row would become 0, 1, 3, 3. I added the bottom row to the second row and changed the second row. My bottom row stays negative 2, positive 2, positive 9, positive 1. Alright, let's put another line here. Alright, now I want to get a 0 here. The only way to do that is to multiply this top row by a negative 2, because negative 2 times 1 would give me a negative 2 right here. Oh, I'm sorry, my fault. Not a negative 2. Multiply the top row by a positive 2. That would give me a positive 2 here, which would cancel with this. So I'm going to multiply the top row by a positive 2. Now I'm going to be a little sloppy here and just do it right here. So 2 times 1 is 2. 2 times negative 1 is negative 2. 2 times negative 5 is negative 10. And 2 times 1 is 2. Now add this top row down to the bottom row and change the bottom row. So my top row is 2, negative 2, negative 10, 2. My middle row is 0, 1, 3, 3. Alright. Add the top row to the bottom row and I get 0. Well, we got 2 for the price of 1. 0, 0, 0, negative 1, 3. Now, I must warn you guys for your test. If you did not get a 0 here, let's say you had 0, 0, and a 3 right here. Always use this middle row to get your last 0. Do not use the top row. No, if you do, you'll get a 0 here, but you'll lose your 0 here. When you go to find your third 0, always use this middle row here. Alright, so, but I got a little bit lucky. I got both 0s here at the same time, so my equations would be put an X and a Y and a Z here, a Y and a Z here, and a Z here. So I have 2X, negative 2Y. You know what? I'm going to reduce. Guys, look, every single one of these terms can be divided by 2. Reduce equations when you can. Divide everything by 2. X minus Y minus 5 equals 1. I divided each one of these numbers by 2 to shrink the equation. Now, if you don't like to do that, don't do it. You don't have to, but it does help, okay? All right, my next equation is y positive 3z equals 3. And my last equation is negative z equals 3. So let's see what happens, okay? Hopefully we got this right. I'm hoping. Alright, here we go. So obviously, if negative z equals 3, then z equals negative 3. That checks. Put a check mark there. And we're done with that. Now, I can put negative 3 in for z right here, okay? So y positive 3 parentheses negative 3 for z, because z equals negative 3. And then multiply. Positive times the negative is negative. Bring the 9 over and make it positive. And y equals 12. Lastly, go to my last equation. X negative y is 12. Negative 5, z is negative 3. X negative 12 positive 15 equals 1. Combine these two numbers. X positive 3 equals 1. Bring the 3 over and make it a negative 3. And I can't believe we got it right on the first try. I actually did not work this problem out ahead of time. But thankfully we got it right, so there we go. Okay, so on your test, make sure you know how to solve equations or solve systems by using augmented matrices, okay? Okay, moving on. Next problem, 47. Solve this by using Cramer's rule, okay? Cramer's rule, here we go. Alright, I'm going to solve for x. So you put x equals, put a big fraction bar, okay? Now up here, you put, down here, you put the coefficient matrix. So 2, 3, negative 3, 4, okay? Piece of cake. Now, for the top, here's what you always do. You copy this matrix, identical except, listen carefully, you see, you understand this is your x column, this is your y column, x column, y column, x's, y's, okay? So here's the thing. Here's the thing, because we're solving for x, you drop out this row. If you were solving for y, you would drop out this row. You're solving for x, so you drop out that row, and you write these constant terms in. We're going to solve for y in a second, I'll show you, okay? So now we're good. Find the determinant up top, and find the determinant for the bottom, we're good. Multiply up, we get a 0. Multiply down, we get negative 68. Combine those two numbers, negative 68. Now find the determinant down here. Multiply up is negative 9. I'm going to put a positive 9. Multiply down, I'm going to get 8. Combine those two numbers and I get 17, okay? Now, negative 68 divided by 17 is a negative 4. So x equals negative 4. Now, yes, we could just take negative 4 and put it in for x, but I want to practice solving for y using Cramer's rule. Now remember, your denominator never changes, so don't forget your determinant of this was 17. Don't forget that, okay? Alright, let's now solve for y. Y equals, up top I'm going to put my denominator, I'm going to put my coefficient matrix, 2, 3, negative 3, 4, okay? Now up top here, I'm going to put the same matrix, okay? The exact same matrix, only now I'm solving for y, so I've got to drop out my y numbers, and in place of those, put these two numbers here. Now remember, there's no work to do down here. I already found the determinant of this a long time ago when I was solving for x is 17, okay? So that's done. All I have to do is find the determinant for the top, okay? Multiply up, negative 51. So I'm going to put a positive 51. Multiply down and I will get a 0. Combine them and I get 51. Well, 51 divided by 17 is 3. Alright, so y equals 3. And there we go. Look at that. Really not too difficult, okay guys? Alright, number That's the good news. Here we go. Let's go ahead and solve for x first. So we write our coefficient matrix down here, okay? So 1, 2, negative 3, 2, negative 1, 1, 1, negative 3, negative 2, okay? So up top, I'm going to put the exact same matrix, okay? The exact same matrix, only I have to drop out the x column. Don't forget that. I've got to drop out the x column, okay? And in place of it, I'm going to put negative 2, 1, negative 7. I got those from the constant terms. Alright, now, let's see what happens. I'm going to copy the first. You guys know how to find the determinant of a 3 by 3. We copy the first two columns over. Same thing up top here. Copy the first two columns over, okay? There we go, okay? Now, multiply up 3 times negative positive 7. I'll put negative 7. Multiply up positive 6, put a negative 6. Multiply up negative 4, so I'll put a positive 4. Multiply down negative 4, leave it the same. Multiply down positive 42. Multiply down positive 1. So combine all those numbers and we get negative 13, negative 21. So negative 21 and a positive 43 would be a positive 22. So if you combine all 6 of these numbers, you get a positive 22. Now, let's find the determinant for down here. Multiply up positive 3, I'll put a negative 3. Negative 3, so I'll put a positive 3. Negative 8, so I'll put a positive 8. Multiply down positive 2. Multiply down positive 18. Multiply down positive 2. So positive 10, 28, 30, 10, 20, 30, and somewhere we've made a mistake. We should get out 1. Alright, let's check our work. You get very careful here. 2, negative 1, 1, 1, negative 3, negative 2, 1, 2, negative 3, negative 1, 1, 1, negative 3, negative 2, okay. Negative 7, that is a positive 6, we'll put a negative 6, negative 4, put a positive 4. Okay, students, pretty simple mistake here. When I combine these 6 numbers here, you do not get 22, you get 30. You can check it and see if you want to, you get 30, okay? And when you combine these numbers here, you get 30. So 30 over 30 is 1, so my x value is 1, okay? Now, please don't forget what your denominator is. Your denominator is going to be 30 the rest of the time through, okay? 30. Okay, students, sorry I had to pause the video, but anyways, don't forget your denominator is a 30. Please don't forget that, okay, guys? It doesn't really matter if you guys see the answer, that's fine. Okay, now, let's go for the y's, okay? So to solve for y, I know my denominator is going to be 30, and my top is going to be, now, let's just skip a step here, guys. Look, we know we're going to replace the y column, correct? Because we're solving for y. So I'm going to have 1, 2, negative 3 for this right here. For the y column, I'm going to put these 3 numbers here, my constant terms. And then for my z's, I'm going to put 1, negative 3, negative 2. Now, to find the determinant of a 3 by 3, I have to copy the first 2 columns over, remember? And so we'll do that quickly and put them over here. And now we're going to get to work. Here we go. We're going to multiply up negative 3, I'll put a positive 3. Positive 21, I'll put a negative 21. Positive 8, I'll put a negative 8. Thank you. Multiply down negative 2. Multiply down negative 18. Multiply down 63. Combine those, you get negative 60. So your whole top of your fraction, your whole numerator becomes negative 60, and your bottom is 30. Negative 60 over 30 is negative 2. Okay? I'm not going to do C for you guys. I'm not being lazy. We've done tons of these, okay? The only thing different for C would be this. C equals, and for your matrix up here, you would drop out your C column right here, and in place of it you would put negative 2, 1, negative 7. We already know the determinant of the denominator is 30. My first row is 1, my first column is 1, 2, negative 3. My second column is 2, negative 1, 1, and then find the determinant of the top, and you should get 30, and 30 over 30 is 1. Okay? Okay, guys, I hope that makes sense. Now, moving on to our next page, I need to do something real quick here and get this thing to follow with me so I know what page we're on. So give me a quick second here while I grab this and copy it, and then go back down here to where we were. Okay, now okay, good. Now this will tell me what page we're on. Okay, we're on page 178. Alright, so on page 178 we're doing 28 and 30. So here we go. Alright, the directions for number 28 say to solve for x. Okay, now this really is not too difficult. I think this is one I gave you on your quiz earlier. This is really not too bad. Okay, look, we know if I take this plus this, it should equal this. I mean, look guys, look at this. 4 plus negative 1 is 3. Negative 6 plus 5 is negative 1. 8 plus negative 2 is 6. So 2x plus 3 equals 5. Guys, that's an equation. 2x plus 3 equals 5. Bring the 3 over, make it a negative 3. Divide both sides by 2, and x equals 1. Now number 30, they want you to solve for x and y and z. But guys, look, it's pretty simple. Look at this. X plus 2y plus z equals 5. X plus 2y plus z equals 5. There's a 0 here, we're not going to worry about that. Y plus negative c equals 3. So y plus negative c equals 3. And then 0, 0, 2c equals 6. Well guys, z is going to be 3. Divide both sides by 2 and z equals 3. That's pretty simple. Now, I'm going to simplify this equation. Y plus negative c is y negative c equals 3. And now z equals 3, so put a 3 in for z. Y negative 3 is y negative 3. Bring your 3 over and make it a positive 3. And y equals 6. So we're cruising pretty nicely here, okay? Now, go to your last equation and solve for x. Where your y is, you're going to substitute 6, right? 6 right here, plus z. 2 times 6 is 12. Positive 3 equals 5. 12 plus 3 is 15, so x positive 15 equals 5. Bring the 15 over and make it negative, and x equals negative 10. Because 5 negative 15 is negative 10. And there is your answer. Okay? Not too difficult, guys, really. Okay? Alright. Moving on. Next is going to be page 184, number 24. 184, number 24. The directions say to solve for x and take this row times this column here, it'll give me this right here. If I take this row times this column, it'll give me this entry here. If I take this row times this column, it'll give me this. And if I take this row times this column, it'll give me this. You have to understand that with multiplication. Okay? So, I know right away if I take this row times this column, it will give me y. So now I know what y is very quickly. This row times this column gives me y. So 4 times 9, 1 times 2, 3 times negative 1. Combine those and you get 35. So y equals 35. Okay? Very good. Now, next we have to solve for x, okay? Let me check and make sure my answer is correct. Yes, that is correct. Now, look, we're not going to use this row. That's obvious because we want to solve for x. We have to use this row here. Now, there's actually two ways to do this. You can take this row times this column and set it equal to this. Or you can take this row times this column and set it equal to this. I'll do it both ways to show you it doesn't matter, okay? Alright, this row times this column gives you this. So, negative 2 times 9, negative 18. X times 2, positive 2x. 1 times negative 1, negative 1. That equals negative 13. So that's one equation. Okay? Now, I can also take this row here with x in it times this column, and it will equal this right here. So row times column, negative 2 times negative 2, 4. X times 1, positive x. 1 times 4, positive 4, equals 11. Well, let's solve this one first. 4 plus 4 is x positive 8. Bring the 8 over, make it a negative 8, and 11 minus 8 is 3. You get the same answer here. Negative 18, negative 1 is negative 19. Bring the negative 19 over, make it a positive 19. 2x equals 6. Divide both sides by 2, and x equals 3. Okay? And that is the correct answer. Alright, x equals 3. Okay? Alright, so there we go. I mean, guys, that's how you do this. Make sure you understand these, okay? Very important. Alright, next problem is going to be page 191, number 18. 191, number 18. Now, we haven't done these for a while. These will be on your test, so you better watch, okay? I'm telling you now to expand along row 3. We're going to expand along row 3. Alright, so here we go. Okay, students, sorry I had to pause the video. Don't know exactly what I last said, but the directions said, say to expand along row 3. Now, here's row 3, obviously right here, okay? Row 3. Now look, I don't care which column you pick, but pick a column. You have to use this here. This is the row we're going to use, and you have to pick a column, okay? So, I'm just going to pick this here, and this here, okay? So, I'm left over with this matrix right here. Alright. And actually, sorry about that, I did make one mistake, I apologize. Let me start over here. We're going to expand along this row here, okay? Right here. So, we're going to go here and here first. So I'm left over with these 4 numbers. I don't feel like I explained that well. I probably confused you. I did make a mistake, and I'm not sure what I was thinking. Let me go over this again, okay? We're going to expand along row 3. This is row 1. This is row 2. This is row 3. Now, it doesn't matter which row you choose, except the directions tell you what row to choose. So that's the row you're going to use. You could also use columns. So on a test, I might ask you to expand along a column. Okay? They're done the same way. In fact, I think when I'm done with this, I'll probably give you an example. The same example, we'll probably expand it by using a column, okay? But let's say on a test, I said expand along row 3. Okay? So we're going to expand along this row here. So what we do is we start with our first number here. Circle this. Cross these off. And so we take this number here we circled. And then we put 4, 1, 2, negative 1 from this right here. answer. It's fine. Now, next we circle the next. Remember, we're moving along what row? 3. We circled this number first. We crossed this off and this off. Now, we're going to circle this number next. So we crossed this off and this off. So the number that's circled is positive 3. Okay? And then my four numbers will be 10, negative 8, 2, negative 1. They're the only numbers not crossed off. Okay? Now moving on, going across my third row, I circle this number, so I cross off this row, this column. So I have a positive 2 because that's the number I circled. And then my four numbers are the only four numbers not crossed off. Okay, now I quickly find the determinant of each of these matrices. Multiply up 2, so I put a negative 2. Multiply down, negative 4. Combine negative 6, so I have 2 times negative 6. Okay, bring down your positive 3 from right here. Now find the determinant of this matrix. Multiply up negative 16, so I'm going to put a positive 16. Multiply down negative 10. Combine, that's a 6. Alright, and then lastly, my next number is a positive 2. Okay, multiply up, that's going to give me negative 32. I'll put a positive 32. Multiply down, that's going to give me a positive 10. That's 42. Now, be really careful with your signs, okay? Please be careful with your signs. After you've done all of this, remember, there's your model 3 by 3 matrix that you have to look at, okay? And it's always going to start with a positive sign here. So positive, negative, positive, negative, positive, negative, positive, negative, positive. I'm not going to get into why this exists, but the positive 2 is right here. So it stays positive. This positive 3 also gets a negative sign here in front of it. So you must also put a negative sign here in front of the 3. Okay? Or if you want to make it easier, you notice you have a positive 3 here, right? So you're going to put a negative sign in front of it. A negative positive makes the 3 become negative. Now, pretend for a second that this 3 right here was negative. So you have a negative 3 right here. Okay? Well, then when you bring this negative down, this sign here corresponds with this number here. Then you'd have a negative, negative 3. That would make it positive, okay? But we have a positive 3, and we're bringing down a negative. So a negative positive makes the 3 become negative. Now, I have a positive 2 here from this right here. What's the corresponding sign with your negative 2? Positive. So put a positive in front of a positive 2. Positive, positive is positive. So now I'm looking pretty good. Multiply, negative 12. Multiply, negative 18. Multiply, positive 84. Negative 12 and negative 18 is negative 30. Negative 30 and positive 84 is positive 54. So I found the determinant by expanding along row 3. I found the determinant by expanding along row 3. Now you're probably getting burned out and tired of this review sheet. We only have one more problem left. Only one. Okay? So let me show you one more thing. I really want to encourage you to watch this. Okay? I hope you will do that. What if I asked you to, let's see here, to expand along column 1. So now we're going to do a column, okay? So expand along column 1. So this is the column you're going to work your way down. So we circle the first number. This is column 1, column 2, column 3. We're going to expand along column 1. So I circle the first number in column 1. Cross those numbers off, cross those numbers. The circle number is 10. And my matrix is 1, 3, negative 1, 2. Next, my next number in column 1 is negative 8. Cross off, this number that's circled is negative 8. The four numbers not crossed off are 4, 3, 2, 2. Do you see what I'm doing, guys? I'm just going down column number 1. Just go down column number 1. So I've circled this number, I've circled this one. Now I'm going to circle my last one. I circle this, that means I cross off this and this. My circle number is a positive 2. My four numbers left over are 4, 1, 2, negative 1. Now, let's find the determinant of our first matrix. Multiply up negative 3, I'll put a positive 3. Multiply down positive 2, that's a 5. So 10, parentheses, 5. Bring down your negative 8, put a parentheses. Multiply up 6, I'll put a negative 6. Multiply down, I'll put a positive 8. Combine, I will get a 2. Bring down your positive 2. Multiply up positive 2, so I'll put a negative 2. Multiply down negative 4, so I'll put a negative 6. Now, don't forget your matrix. You've got to check your signs. Positive, negative, positive, negative, positive, negative, positive, negative, positive. Okay? We expanded along column 1, right? So your first number gets an extra positive sign. That's okay. It's already positive. Put another positive sign. Positive, positive is positive. No big deal. Then I come down to my negative. Well, there's already a 1 sign here in front of the 8. Negative. I'm going to put another negative. So negative, negative makes the 8 become positive. Now my last sign is positive. I've already got a positive 2. Put another positive sign here. Positive, positive is positive. So we're okay. 10 times 5 is 50. 8 times 2 is 16. 2 times negative 6 is negative 12. 50 plus 16 is 66. Minus 12 is 54. Okay, so make sure you can find the determinant of a matrix of 3 by 3 by expanding along rows or columns. Last and finally but not least, page 200, number 24. Page 200, number 24. And they want us to decide whether the matrix has an inverse. So I want you to look at this matrix and say, yes, it has an inverse, or no, it does not. Okay? Yes or no. Well, in case you've forgotten how to do this, let me refresh your memory, okay? Anytime you're going to find the inverse matrix of a given matrix, are you listening? If the determinant equals what? 0, then there is no inverse matrix. So listen, if all they're asking me to do in number 24 is state whether the matrix has an inverse, students, dudes, all I have to do is just find out whether this matrix has a determinant other than 0. So all I have to do is find the determinant of this matrix right here. And if it's 0, then I know there's no inverse matrix. If it's any number, positive, negative, whatever, any number not 0, then I know that this matrix has an inverse. So I can do this pretty quickly. Just copy, you guys know how to find the determinant of a 3 by 3. You copy the first 2 columns over again. And I did not want that, that's for sure. There we go. And let's go to town on this and get it done quickly. And we're done with the review sheet. Multiply up, you get a 0. Multiply up, negative 4, so I'll put a positive 4. Multiply up, positive 1, so I'll put a negative 1. Multiply down, 0. Multiply down, positive 3. Multiply down, positive 4. Combine, and you get, it's not 0, that's for sure. 8, 11. 11 minus 1 is 10, unless I messed up, which I very well could have. I did it quickly, but I'm getting a determinant of 10. So the determinant is not 0. Now if it would have been 0, if my determinant would have been 0, then I would have said no inverse matrix. But since my determinant is not 0, then my answer is yes. This matrix here does have an inverse. Yes, it does. Okay, guys, I hope this review sheet help video has been a help to you. If you have any questions at all, never hesitate to call or email.